Ever dive into Google Earth Engine, search for Sentinel-2 data, and just stare at the options, wondering where to even start? Yeah, we've all been there. If you've ever asked yourself, which one of these do I actually use? Well, you've come to the right place.
So first, a super quick refresher. Google Earth Engine, or GE, is this incredible cloud-based platform. It gives us access to a gigantic catalog of satellite imagery and all sorts of geospatial data. It's really like having a planet-sized supercomputer right at your fingertips.
But, all that power brings a bit of a challenge. When you search for something as fundamental as Sentinel-2 imagery, you're immediately hit with choices. And picking the right one, that is the absolute first and honestly most crucial step for any analysis you're going to do.
So, to get you going on the right track, here's what we're going to cover. We'll look at the world of data we're dealing with, break down the Sentinel-2 menu, really get into the difference between raw and refined data, see it in action, and then wrap it all up with a quick start guide. Now, a lot of this data explosion comes from the European Space Agency's Sentinel-2 mission. It's capturing these super high-resolution images of the entire globe every couple of days. GEE puts this amazing, constantly updated library right in our hands, which means we just need to know how to navigate it.
Okay, so picture this. You're in the GE data catalog, you're ready to start your project. You type in Sentinel-2 and you're immediately faced with a choice. Now, this is where a lot of people get kind of tripped up, but I promise it's actually pretty simple once you know what you're looking at.
You're going to see two main products that pop up, Level 1C and Level 2A. I know they sound super technical, right? But the difference between them is going to fundamentally change your results. So what really sets them apart?
It all boils down to one simple thing: the level of processing. You can kind of think of it as choosing between a raw, unedited photo straight from the camera versus one that's been professionally touched up and is ready to be put on display.
So here's the bottom line. Level 1C gives you what's called top of atmosphere, or TOA reflectance. Just think of that as the raw data. Level 2A, on the other hand, gives you surface reflectance, or SR. This is the refined, analysis-ready good stuff. But what do those terms actually mean in practice? Let's use an analogy here. Top of atmosphere data is like taking a picture of the ground from space through a slightly hazy, maybe even dusty window. That haze, that's our atmosphere. So the image you get is a little distorted by things like water vapor and dust. It's the light just as the satellite sees it.
Now, surface reflectance data, that's the same photo, but after scientists have digitally cleaned the window. They've used algorithms to remove all those atmospheric effects. What you're left with is a much more accurate picture of what the Earth's surface truly looks like. So for pretty much any land-based analysis, this is the one you want.
And here's a huge pro tip, coming straight from Google's own documentation. A little while back, the way Sentinel-2 data was processed got a slight update. So to make sure you can still compare images from before and after that change, Google created these special harmonized datasets.
So here's the simple rule. Whether you're using top of atmosphere or surface reflectance, always choose the collection that has harmonized in the name. This guarantees that you're comparing apples to apples across the entire archive, which is absolutely critical if you're trying to track changes over time.
Okay, enough theory. How much does this choice actually matter in the real world? When the rubber meets the road, what's the impact? Let's take a look at a case study.
And it's a fair question to ask. Does taking the time to pick the right data set, like the one that's been atmospherically corrected, actually make a noticeable difference in your final map? The answer is a huge, definitive yes.
A study from the Forestry Journal of Nepal gives us a perfect example. Researchers wanted to map out the land cover for the city of Pokhara to help with sustainable planning. They used high-quality Sentinel-2 data to classify the whole area into different types, like forests, farms, city areas, and water.
And you can see their findings right here. By using that more detailed, spectrally rich Sentinel-2 data, they were able to create a land cover map that could distinguish between all the different classes on the ground way more accurately. And for urban planners, that's crucial.
And we can even put a number on that success. Their final classification using the Sentinel-2 data achieved an overall accuracy of 83.70%. That number is proof positive. Making the right choice up front leads directly to results you can actually trust.
So picking the right product, like that Level 2A surface reflectance, is step one. But the power of Sentinel-2 doesn't stop there. See, it captures light in 13 different spectral bands, and by combining them in different ways, we can basically create unique lenses to highlight really specific features. Here are just a few of the most popular recipes. A 4-3-2 combo gets you natural color.
That's what your own eyes would see. But switch that to 843 for color infrared, and suddenly, healthy plants just glow bright red. Other combos can make cities pop in purple or reveal subtle differences in geology that are totally invisible otherwise.
And check out this incredible example from Bahrain. On the left, that's the natural color view. But on the right, using that color-infrared combination, all the vegetated areas, farms, parks, they just jump out in this vibrant red. This is the power of using different bands to tell completely different stories about the exact same piece of land.
Okay, I know that was a lot of information, so let's boil it all down to the absolute essentials. If you just remember these few key things, you'll be all set for your next project in Google Earth Engine.
Okay, first, Sentinel-2 has two main flavors. Level 1C is the raw data, and Level 2A is the refined analysis-ready data. Second, for pretty much any analysis of land, you want to use Level 2A surface reflectance. Third, and this is a big one, always use the harmonized version for the most consistent data over time. And finally, just remember, these choices aren't just technical, they directly impact how accurate and reliable your work is.
So by understanding these simple principles, you've really unlocked the full potential of the entire Sentinel-2 archive in Google Earth Engine. You're no longer just looking at data, you're ready to ask meaningful questions of it. So the only question left is, what are you going to discover?